All right, everybody, welcome back. In this video, we're going to be looking at information from Section 7 of Unit 2 of AP Calculus, the derivatives of cosine of x, sine of x, e to the x, and the natural log of x. So the first thing that we're going to do here is we're going to actually explore what the graphs of the derivatives of these functions look like and see if we can guess what we think their derivatives are going to be. So we're going to go ahead and start with the function sine of x, and I'm going to use Desmos to help me out here. And so what I'm going to do is first I'm going to go ahead and graph y equals sine of x. And there we see the graph of the sine. And now on that same graph, I'm going to graph, the derivative of sine of x. Okay, so in blue here we see the graph of y equals sine of x, and in green we see the derivative of sine of x. Now the question is, what does it look like to us the derivative of sine of x is equal to? Does that look like another function that we know? And to me, it looks kind of like it might be the cosine function. I'm just going to take a guess and say maybe that is y equals cosine of x. And boom, we see that that purple graph perfectly covers up the green graph. So it appears that the derivative of sine of x is cosine of x. So that's going to be my guess here. I'm going to go ahead and put that in my table, cosine of x. Okay. Let's try the same thing for the function cosine of x. So I can just leave cosine of x on my graph. There's cosine of x. And I can graph the derivative of it. Looks like another, maybe it's the sine of x, maybe it's something else. Let's see, why don't we try y equals sine of x. Oh, nope, the red graph and the black graph aren't the same. But if we look at them, it looks like the black graph and the red graph are just mirror images of one another, flipped upside down. So I think if I just take the opposite of this sine of x, it's going to give me the same graph as the derivative of cosine. And if I put that minus sign in there, ba-bam. And so we think that the derivative of cosine is the opposite of the sine. So I'm going to go ahead and put that in there as our guess. All right, next, let's put in y equals e to the x. All right, there's y equals e to the x. Slide the graph up a little bit. Now let's go ahead and graph the derivative of e to the x. Oh, I made both of those graphs purple. Let's make this one red. Oh, wait a second. If I turn that off, if I turn it back on, looks like it's the exact same graph. Looks like the derivative of e to the x is just e to the x. How about that? So I'm going to go ahead and fill that in. And the last one, and this is probably going to be the hardest of the bunch that we've seen today. Let's do y equals the natural log of x. It's a natural log function. Okay, and let's go ahead and we'll graph the derivative of the natural log of x. Now the question is, what does that graph look like? That red graph, does that look like any other function that maybe you've encountered somewhere before. And again, this one I don't think is as obvious as the other ones. But to me, it looks a lot like the graph of 1 over x. The only thing is that it only looks like the graph of 1 over x for x values greater than 0. And of course the reason for that is because the domain of the natural log function is x greater than 0, and we talked, and I feel like I just casually mentioned it, several sections ago, that when we have a function, the derivative of that function starts with, at most, the domain of the original function. So since the domain of the natural log of x is x greater than 0, the domain of its derivative is also going to be x greater than 0. I don't know if you can hear the sirens going by my house. I don't know what's going on. And so the derivative of this is 1 over x, but x has to be greater than 0. So my derivative here, I'm guessing, is 1 over x as long as x is greater than 0. Okay, so there are my guesses for what the derivatives of all those functions are. And what we're going to do, continuing on from here, is we're going to develop these derivative rules and see if we end up with the same thing that we did the first time with our guesses. So we're going to start by developing the derivative of the sine of x. By the way, I mentioned here, now that we have our guesses, we're going to develop some of the rules. And it says here, just, to ramp your anxiety up, I'm going to really help you with the last one because it is very difficult for us to develop that with what we currently know in this course. It's hard to do the development of that. And so we're going to do some things that we don't really know how to do yet in order to find that rule. So let's start with developing the derivative of the sine of x. So we're going to set up our limit of our difference quotient. F prime of x is the limit as h goes to 0 of the sine of the quantity x plus h minus sine of x all over h. And, a lot of times what we've done here at this point is, try to simplify things algebraically, but since this is the sine function, we can't really simplify anything algebraically unless we know how to expand the sign of the quantity x plus h. Hopefully you do. If you don't, it is a trig identity that you should have somewhere in your back pocket from pre-calculus, and that is that the sign of the quantity x plus h is equal to the sine of x cosine of h plus sine of h cosine of x. Okay? And now what I'm going to do is I'm going to go back and use some limit properties that we had, and I'm going to group this into two different limits. I'm going to group this into the limit containing the terms from the numerator that have sine of x in them, and another limit containing all the other terms. And the denominator h is going to be the denominator for both of those limits. And so this is going to be equal to limit as h goes to 0 of sine of x cosine of h minus sine of x all over h plus limit as h goes to 0 of sine of h cosine of x all over h. All right. Now from here, I'm going to do a little bit more algebraic manipulation. In this first one, I'm going to factor a sine of x out in the numerator. That's cosine of h minus 1 all over h. And now that I get to here, all of the factors that contain x's in them are constant with respect to these limits because h is the variable component of these limits. And so I can factor the constants out of the limits using our constant multiple rule for limits. So I can factor the sine of x out in front of this first limit. And I can factor the cosine of x out in front of the second. And then I just need to take these limits, if I don't already know them. Limit as h approaches 0 of cosine of h minus 1 all over h. I don't know if... Do you know that one off the top of your head? If you don't, I'm going to go ahead and use a table on my calculator to find this quickly. So we're going to put in cosine of x minus 1 all over x, and we'll build a table around 0. And we look at that table, and it looks like as we approach 0 from both sides, that's approaching 0. And the other limit, limit as h approaches 0 of sine of h over h, is one that everybody should know. But if you don't, go ahead and, like I said, this is one of those limits that everybody should know. The limit as x approaches 0 of sine of x over x. That limit approaches 1, and so we've got sine of x times 0 plus cosine of x times 1. That tells us that the derivative here is cosine of x. And lo and behold, that matches our derivative that we guessed. Okay? All right, I think we're going to call it quits there for this video. We'll come back in the next one and we'll develop the rules for the derivative of cosine, the derivative of e to the x, and the derivative of natural log of x, and get started with a couple examples. If we have time, we might end up spilling into a third video on this section. But that's it for this one. Come back and join me for video 2, and I'll see you next time. Have a great rest of your day, everybody.